To represent the formation of bonds between atoms, it is convenient to use a system known as electron dot notation. In this notation, the symbol for an element is used to represent the nucleus of an atom of the element, plus all the electrons except those in the outermost shell. The outermost electrons are represented by dots. Let's see a concrete example. For the following atoms, I will show you the electron dot notation. For the first one, hydrogen, the number of valence electrons is equal to 1. So the electron dot notation will be using the symbol of the element, so hydrogen here, and next to it a dot representing the outermost electron, as seen here. For lithium, the number of valence electrons is also equal to 1. So we will place a dot next to the lithium atom to represent the electron dot notation. Carbon has 4 valence electrons, so we will use 4 dots to represent the electron dot notation. 1, 2, 3, 4. Oxygen has 6 valence electrons, so we will use 6 dots as seen here. Nitrogen has 5 valence electrons, so we will use 5 dots next to the symbol of the element nitrogen. Sodium has 1 valence electron, so only 1 dot next to the symbol of sodium. And fluorine has 7 valence electrons, so 7 dots to represent the electron dot notation for this element. Using the electron dot notation, the production of sodium fluoride and calcium fluoride may be pictured as follows. A sodium atom and a fluorine atom react in a ratio 1 to 1, since sodium has 1 electron to lose from its outermost shell, and fluorine requires 1 more electron to complete its outermost shell. So this gives the sodium ion Na+, and the fluorine ion F-. To lose its entire outermost shell, a calcium atom must lose 2 electrons. Now, since each fluorine atom needs only 1 electron to complete its octet, it takes 2 fluorine atoms to react with 1 calcium atom. Calcium will become Ca2+ with 2 fluoride ions F-. Now let's get some practice. With the aid of the periodic table, let's use the electron dot notation to determine the formula of the ionic compound formed between lithium and oxygen. Lithium is in group 1a of the periodic table, and so it has 1 valence electron. The electron dot notation for lithium is shown here. To lose its entire outermost shell made of 1 electron, lithium atom must lose 1 electron. Oxygen is in column 6a, and therefore it has 6 valence electrons, and the electron dot notation for oxygen is seen here. From this electron dot notation, we can see that an oxygen atom needs only 2 electrons to complete its octet, and therefore it takes 2 lithium atoms to supply the 2 electrons needed by 1 oxygen atom. In this compound here, each lithium atom will lose 1 electron to give the following lithium ion, and the oxygen atom will capture the 2 electrons provided by lithium and will form the oxygen ion O2-. The formula of lithium oxide is Li2O.